Raise your hand. And let us pray. In nomine Patris, et Filii, et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in predica, contra nequitia et insidias diaboli, est presidio. Impere, ille Deus, supplices et precalculum, tuque riches malitia celensis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum pervigantur in mundo, divina virtute in infernum destruit. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Okay. And ladies, I'll check your stuff at the end of the hour. Ladies, I'll check your stuff at the end of the hour. Remind me so I don't spit it out. All right. This catches us up from yesterday, I think. The situation is this. We have 1,200 feet of fencing, and they're setting up, whoever the mystery they are, setting up a rectangular pen for sheep. And I want to know what dimensions would maximize the pen area. We don't know yet. And guess and check is really super tedious. There were loads and loads of combinations. You could have 1, 1, and 1198, which would be pretty dumb and cruel to the sheep. You could have 10, 10, and 1180 or something like that. It would take, a long, long time to figure out which one of those would be maximum. And there's no guarantee that the numbers are whole numbers. So guessing and checking would be something of a nightmare. Fortunately, there is something else we could do. Can anybody tell me how much fencing we have total? Just to catch us up from yesterday? 1,200 feet. So I can do that. I have 1,200 equals x plus 2y, and a is equal to xy. Now, ultimately, they're asking us to maximize the pen area. One way to do that, write this down. Graph it, then find the maximum height. The maximum height should be the maximum value. In other words, if I'm going to graph the area. Now, does anybody see a potential problem with graphing this? I mean, you don't have to have y equals in front to get a equals, I suppose. But there's something wrong, something very wrong. As a matter of fact, I don't know what it is. What's making this so complicated to read? Actually, I'll tell you right now, it's not going to be a line. But there's something very strange about this. Have you ever graphed anything with x's and y's in it before? Like multiplied together? I don't think you have, and I don't either. Has anybody ever graphed something with 3 variables? I think you would remember because, oh my goodness, I won't say it hurts, but wow. It's called the 3-dimensional graph, which we are, by the way, going to touch on at the end of the semester. But for right now, circle this. There are too many variables. Whenever we had a function, all of the letters were x's. We need all x's. That means I have to get rid of the y. You have a brilliant idea how to do that. Now, you can't just erase it. Oh, that was easy. Now, it's still there. If I could only find what y, if somebody said, by the way, y is equal to 100, that would be awesome. I could just plug it in. Even if somebody said, hey, y is equal to 2x, that would be wonderful. Is there anything that could possibly give us a clue as to what y might possibly be? Okay. How? Like, what do I do? Where do I start?
problem on the left.
Yeah, right here. I've got x, 2y, and blah, blah, blah. By the way, this is a line. But can you get y by its own? Go for it.
Subtract x.
Subtract x. So I have 2y equals negative x plus 1200. I like to put the letters before the numbers. And one more step.
Divide by 2.
Divide by 2. Tell me whether you get y equals, what is this really?
Negative 1/2 x.
Good. Negative 1/2 x plus
600.
Good. That's definitely a line, and it's a lot nicer than it was before. What am I going to do? Well, in this original equation, and nobody would have known this until I told them, when you're doing a problem like this, the only way to solve it is with graphing, as far as we know. And the only way to graph it is to have only one type of letter here, usually x. X is our input variable. So I need to replace all of the non-x's with x. It looks like we can do that now. See what it looks like. We have the area is equal to x times negative 1/2 x plus 600. Somebody simplify that for me. That's it. Is that simplified at all? What could you do? Distribute the x. What do you get if you do that? So negative 1/2 x squared plus what? 600x. That is the key to the whole problem. Can you tell me what shape that would be if I did graph it? What shape is this if I graphed it? So again, it'd be a line if it weren't squared.
Oh,
Parabola, right. If it's squared, it's going to be a parabola. Can somebody tell me if the parabola is opening up or opening down? Go. How do you know it's opening down? Negative. The height multiplier is negative. So we could actually graph this thing. Oh yeah, I gotta stay on the screen here. Where can I put it? How about here? I'm just gonna fake it. We did a chapter test where you graphed one of these things. Tell me how. Who can step me through it? Where do you start? Is there any piece of information you can tell me at all, other than the fact that it opens down, which is good? How do you find the vertex? How do you find x-intercepts? How do you find y-intercepts? How do you find anything? Who's feeling brave and or courageous and or reckless? Okay. Can someone tell me where the axis of symmetry is? Or the x-intercepts, either one of those would be relatively good to start. This is in standard form right now, with one tiny exception. There's a number missing. Is that missing? Yeah, plus 0. If you want to use the quadratic formula, you can. What does the quadratic formula find, by the way? Austin? X-intercept, so the solutions, yeah. If you ignore the plus 0, you could get it into another form. Anybody see it? What are the three forms of a parabola that we studied? We've got standard form, and then what two other ones? Okay, give me another one. Vertex form, and then there's one more. X-intercept form. X-intercept form is after you factor. Ignore the plus 0. Is this same factor? Yeah. How so? I'm sorry? Take out the x, and there's something else. You could take out the 1/2. That's actually kind of bright. But kind of bright. That sounds like a backgammon compliment. It's very bright. But there's one last thing I got. That's actually kind of, sort of, a little bit bright. It was quite good. There's one more thing you got to pull out though. The negative. If the first term is negative, pull out the negative. Go ahead. What do you pull out? Second. negative a half x. Tell me what's left. That's logical. However, when you're dividing by a half, what does that actually do? It multiplies by the reciprocal. If this is half as big, guess what this is going to be now? Correct. 1200. Positive or negative? Okay, I gave it away. But negative. Why? Started out positive. Right. When you pull out a negative, you divide by a negative and everything flips. Can somebody tell me where the two x-intercepts are? Just looking at this. Let me see. Well, where are the x-intercepts? How do you find x-intercepts? Like if you're doing a chubby hand method with a line, how do you find an x-intercept? Okay, all x-intercepts have something in common. Like, here's an x-intercept, here's an x-intercept, here's an x-intercept. All these points have something in common. Look at the coordinates. Thank you, with my way, thank you. Don't yield to temptation. They all have something in common. Oh, y is 0. That's exactly how you find them. To get an x-intercept, you pretend that y is equal to 0. Now, there is no y, but when you're graphing, you can kind of pretend this is y. So set that equal to 0. Something times something is 0. How do you do that? Yeah, what property is that? Zero product property, exactly. So negative 1/2 x equals 0, or x minus 1200 equals 0. Tell me what those would give you. What x equals what? This better be 0, yeah, and this one should be 1200. You've just found the two x-intercepts. My main goal is to graph this thing. Once we graph it, we should be able to find the maximum height, which by the way is called the vertex. We've got a dot at 0, and we've got a dot way over here at 1200, which is a huge graph. Can somebody tell me anything else about this problem? Mary, is there an object you could find based on these two? Axis of symmetry. Where would you look? Halfway between. Where is that? 600. X equals 600. I'm going to put a dotted line there. The axis of symmetry is x equals 600. What good does that do? All right, what do you think? What use is that? Other than it's on a text. That's one of the points of the vertex. Question, is the vertex going to be above or is it going to be below?
Above.
It's got to be above. Why do you say that?
Because it's negative parabola, so it's backwards.
Yeah, it's a negative height multiplier for a parabola, so it's got to be going down. So it had to start from above. So I'm going to draw it like this. So I know that this is a vertex, and it's 600, comma, something. Somebody tell me how to find the something. Very clear. How do you find the height if x is 600? Plug it in, exactly. Plug it into this monster. Let's do it. Pretend that x equals 600. I'll just kind of grind this out. Hang on a second. This is going to be very big. Negative 1/2. I apologize ahead of time. It builds character. 300 squared plus 600 times 600. Yeah, I know. 600 times 600. 36 and 4 zeros. 360,000 times negative 1/2. Is everybody okay with that? Everybody know how I got that so fast, by the way? There's a trick to it. It's not because I'm super brilliant, right? I'm not, trust me. Yeah.
You squared 6 and then doubled the amount of zeros.
Yeah, if you square 6, it's 36, and And then however many zeros you started with, when you square it, you double the number of zeros. If you cube it, you triple the number of zeros, and so on. Anyway, this is another 360,000. And this is negative a half of it, so negative 180,000. So, everybody know what it is? I don't want to spoil this for us. I'm sure everybody's staying up late at night and thinking, sorry mom, I can't go to bed. I need to find out when 360,000 minus 180,000 is. It's killing me. Let's see. Becca. What's 36 minus 18, by the way? Okay. 18. So 36 blah 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 plus 18, so it's going to be 18. 180,000. Go ahead and write that down. We have largely finished our problem. Now, what you found was the value of x, and then the area it causes. Go back to the original problem. If this works properly, you're going to have 180,000 square feet. Got one. But can anybody tell me how big the bottom of the rectangle is? Yeah. It's 600. That was the x we found. 600 what? Feet, because that's what the fence was measured in. Can somebody tell me what y is? How do you find it? Other than the conspicuous math teacher elbowing his way for it. Abby, if x is 600, how do you find y? Exactly. Plug it in. So we have y equals negative a half times, what was x again? 600. Plus 600. All right, what's half of 600? Yeah, what's negative a half of 600? So negative 300 plus 600 is what? Got it. You just found your other measurements. 300 what? In this case. Anyway. Feet. Done. Let me step you through from beginning to end what we did. They set you up with a story problem, which is I know everybody's favorite. I'll tell you a story about that in a minute. But they said, here is a rectangular pen. There's one wall you don't have to worry about, and then there are 3 walls you do. And if it's rectangular, these 2 have to be the same height. Other than that, they told us nothing, except for 1,200 feet of fence. So I had to name my own sides. I would suggest you name them with x's and y's, because those are easy to graph. So we have x is something, y is something, and y is something. So is everybody okay so far? Like, as soon as they gave the story problem, we drew a picture. It says, there's a 3-sided rectangular pen smack up against a wall where you're going to hold sheep with 1,200 feet of fencing. Boom, boom, boom. And then right over here, 1,200 feet of fencing. I immediately named these x and y. You could have called this x and this y. I don't care. It works either way. But, does everybody see how that does so far? We're going to do another one in a minute. After that, they were talking about the amount of fencing. Like, this is actually how to do detective work in a story problem. People get frustrated with story problems because 2 reasons. Number 1, they're in English. They said, just give me a math formula and let me solve it for crying out loud. And then the second, it's like, which of these pieces of information are useful and which are not? The fact that they're talking about sheep is not all that relevant. You could put cows in here and they're dumber, but it doesn't make any difference. But the measurements do. If you look through the entire story, it's that there are 2 things that caught my attention math-wise. They talked about the length of the fence, 1,200 total, and they talked about area, because they want to maximize the area. Those are the only two things they mentioned. Whatever they mentioned mathematically, write a formula for it. Let me write that down. This is universally true with any story. I just boxed myself into a corner. Can I? Yeah, go. Would it be okay if I erase this part? We need some space. So quick summary in story problem translation. Step 1, draw the scene. Whoops. If possible. Draw the scene if possible. If they're talking about a rectangle, draw a rectangle. If they say somebody's mowing a equilateral triangular yard, which would be strange, but draw an equilateral triangle. In the instant they talk about something mathematical that you can picture, draw it. Draw the scene if possible. Label the parts that you can. Even if only with variables. Okay. The story problem in this particular case talked about a total of 3 things. It talked about length of fence, it talked about area, and then it asked for the dimensions, the length and width. Those are the things I'm going to label. I'm going to label the area, I'm going to label the sort of perimeter, and I'm going to label the dimensions, X and Y, and then I'll have a formula for the fence, I'll have a formula for the area. That's how I label it. Okay. Step 2. Find all relevant numbers and plug them in. They will give you some numbers, plug them in. If they give you the total area is 1,200 square feet, plug that in. If they said the total amount of fence is 1,200 linear feet, plug that in. And then 3, simplify and solve, which usually involves 2 or more formulas. Not always, but usually. That's the general rules for story problems. Let me try a scaled down version of this. In a sense, this is easier, and in a sense, it's more frustrating, because people just sort of stare at it and wonder. If the sum of 2 numbers is 40, find the 2 numbers that maximize their product. Let me write that down. If the sum of 2 numbers is 40, find the 2 numbers that maximize the product. First of all, let's go through this. Draw the scene if possible. Is it possible? Not very. I mean, you could draw a formula, I guess. The sum of two numbers. What does that mean, math people? Taylor, what's a sum?
Addition.
Addition. Two numbers. Did they say what they are?
No.
Tell me what you want to call them.
X
X
and Y.
and Y. How would you make a sum of that? X plus Y, and it should equal what?
40.
Ta-da. You're about a fourth of the way done, just by writing that. What do you think they call that? Find the two numbers that maximize the product. They're telling you about something else now. Will, what mathematical operation is this? Say again? Multiplication. How would you write that? X times Y. Now, they didn't tell us what it was equal. Just put an arrow and say, make it maximum. I'll also give you a hint. Max and min usually involve a graph. If it's a maximum, it's probably a parabola or something like that with a vertex or maximum point. Or if it's a minimum, it might be a regular right side up parabola with a bottom point. Okay. Find all relevant numbers and plug them in. I think you did. There's the number 40. Simplify and solve involving two or more formulas. Can somebody tell me what to do next? Yeah.
Use the first formula and get Y by itself.
Okay. Why would we do that?
So you graph it.
Graph it. Yeah. Are you going to graph the sum or the product?
The sum.
The sum is easier to graph. I'll give you that.
I'll just do the product.
Why?
Because that's what you're trying to find.
Right. We're trying to find the product that's the highest. In other words, if I want to find the maximum, like the maximum product, this means you have to graph the product. Does that make sense? Whatever you're trying to maximize, graph that. Now, it's a little confusing because there's already, I should have used A to B actually, but man, whatever. If I get Y by itself, let me see, Nate, what's Y if you get it by itself? Use a little algebra. Y equals 40 minus X. Put it in the right order. Negative 1x plus 40, good. Did we see why this subtraction is not commutative? So we got this. What would you do with that? Nice. Why would we get y by itself? Yeah, plug it in to the area or to the product formula. Tell me what this is. So the product is equal to what now? It used to be xy. What is it now?
X times 3 plus
40. Following so far? Somebody simplify that for me. Okay. Negative 1x squared plus 40x. Now, if you want to graph, what do you put in front? I mean, if you're graphing something, what's the code for that in front? Y equals. What shape is this going to be? Okay. Parabola. Is it going to be opening up or opening down? Down. Why do you say that? Yeah, height multiplier is negative. So, Rainey, can you factor this for me? What's the first type of factoring you always look for? GCF. Is there one? Yes, like what? Definitely X. And one other thing. Good. Negative. So y equals negative 1x, parentheses what? X what?
Oh,
Minus 40. Nice. Can somebody tell me the two x-intercepts? Hey. Because I just want to graph it somehow. You don't have to do this, but it's easy. 0. X equals 0, and the other one is? Exactly. Nice. Everybody see where we got that? If it factors, use that. By the way, what would you do if it didn't factor? Find the axis of symmetry some other way. Use the quadratic formula to find the roots, or you could get this in vertex form called completing the square. Let's graph this thing. Get a root at 0 and a root at 40. Can anybody tell me anything else interesting about this thing? Mary, what other object can you find? Did I ask you this last time? Okay, I'll stall you on this one. So, Will, how do you find the axis of symmetry?
We'll just find the average.
Yeah, what is the average of 0 to 40? 20. Correct. I realized that just a little too late. So x equals 20. Would the vertex be, well, would the vertex be above or below?
It would go above. No, sorry, it would be above.
Above
It's
what?
going down.
Yeah, it's going down, so it has to be opening from above. So this vertex has to be 20 comma something. Mary, how do you find the something? Yeah, plug 20 in where? Exactly, and take either whichever one you want. I'll use this one. Let's do it there. So plug in 20 for me. Y equals -1 times 20 squared plus 40 times 20. Calculate that for me. What's this? And then it's -400 plus 800 is 400. You just found the vertex. Somebody tell me what this is and what this is. There's one thing that's a little dangerous. I should have done this. When we're graphing, do me a favor. On the graphs, put a capital Y. I'm sorry to change that later, and these will have to be capitalized too. I'm wondering if everybody sees why I had to do that. Why would I be so mysterious? Why just leave it alone? This Y and this Y are two different things. This Y is just whatever mystery number, second number. This Y is the artificial one I brought in for graphing, because Y equals means graph. But it's not the same as this. That's kind of why I wish I had done A plus B or something. But as long as I have this, can somebody tell me what this represents? Let's see. X. This is X. X equals 20. You have just found one of your two numbers. By the way, can anybody find the other number? It's actually pretty full off a log easy now. Awesome. What's Y? It's also 20. How do you get that? Yeah, 20 plus 20 is 40. You have just found the two numbers. X is 20, Y is 20. If the two numbers are the same, then the product is the biggest. 20 times 20 is 400. Just for fun, yeah, questions?
So, wouldn't you just find the axis of symmetry instead of the vertex of
Yes and no. Well, for the purposes of this thing, yes. The axis of symmetry, what she asked is, can you just find the x and forget about this y? In this particular problem, yes. If a little later on I said, so what area did it, or what product did it give you? That's the answer there. So could you do that by hand too? Yeah, I suppose. So I guess the short answer to your question is yes, you don't absolutely need this. There are some problems where this would be a lot handier. So don't throw it away. But yeah, the question was, can we just take the x and run? Yeah, you could. As long as you know how to do the math over here, that should be safe. Does that make sense? All right. right, take out your book, please. We're looking at, and I've got I apologize on behalf of the computer again, those kind of psychotic numbers around. This is to D as in David. It says 1 through 7 odd. That is not correct. I'm just going to completely replace the numbers. And by the way, people listening at home, I'll put it on the board in just a second. I won't leave you out to dry. We're looking at page 71. The reading starts on page 68. So it says, right now, it says 1 through 7 odd and 11 through 26. That is definitely not true. First of all, there aren't 26 problems anyway. I would like you to do number 1, number 3, and oh wow, that's kind of scary. Oh, wow. Oh, hold on. I'm sure of them.
They're old phones.
I guess that's only one and 3. I do have to tell you, they're going to ask you one extra question. It's very easy to do, but if you don't remember 2 months ago, it might be hard. Does anybody remember what domain is? What's the definition of domain? There's domain and range. 3 words. Yeah.
Is the name like Y?
It's the other one.
X?
Domain is the X. All legal inputs. Domain. All legal inputs. That's usually the X's. They're going to ask you for the domain. Look on this particular problem. You've got x plus y is equal to 40. Or actually, let's think of our the sheet pen. How many feet of fence could you use? I remember. What was it again? 1,200. Correct. I'm with you. That's backwards. I had the x's in. So question, what's the domain if the fence is 1,200 feet? What are the logical limits on x? Because you can't have 5,000 for x, it's too much, you'd run out of fence.
Has to be greater than 0, but less than.
Yeah, first of all, x definitely has to be greater than 0. If it isn't, I need to talk to you about how you build pens. Go ahead.
It also has to be less than. Could it be equal to 1,200?
Maybe. Could it be up to 1,200? Sorry, 1,200. Yeah, I guess 1,200. Could it be 1,200? Could it be exactly equal to 1,200? No, because you'd crush it flat. Y would be 0, and you'd have a bunch of flat sheep. You have sheep even, a thinness of a sheet of paper wouldn't be able to fit in. So, no. Unless you have a bunch of 2-dimensional sheep walking around, in which case, talk to me. We'll get you famous. It has to be less than 1,200. Does that make sense? Is there a limit on y? I mean, y has to be bigger than 0 too, but is there an upper limit on y? Think about this for a second. Yeah. What's the highest it could ever go? Just no matter what, in this case. 1,200. Does that make sense?
Yeah, that makes sense.
Is there a better upper limit?
Is there what?
Is there a better upper limit than that? You definitely cannot go above 1,200. But look at the picture. there's a lower limit than that. What? How do you get 600? There's two of them. If you extend this down and you make this 600, this is also 600. So the y's, it's going to be y is greater than 0, y is less than 600. That would be the range. Does that make sense? Or the domain of y, if you want to be weird. So this would be the domain. They're looking for the inputs that are legal. Anywhere from something to something. So it's probably bigger than 0 and less than something else. Okay, so number 1 says farming. A farmer wants to make a rectangular enclosure. Oh, funny. They use the same set of ideas. They use X instead of Y, but whatever. 120 meters of fence. Meters. But otherwise, it's the same sort of problem. Express the area in terms of X and state the domain. In other words, what are the limits on X? And then part B, solve the problem. Everybody good? Alrighty, you got about 10, 11 minutes. Go ahead and start hacking away at that. You're welcome to work in groups or alone, as you like. And people listening at home, oh yeah, let me write this on the board. This is number, yeah, hold on, don't turn it off yet. This is homework number 2D. I just want you to do problems 1 and 3. Okay? So people listening at home, homework 2D is in David, just number 1 and number 3, and that's it. Okay? So God willing, it'll work. Take care. God bless. This is my hand waving goodbye. Can somebody tell me if I'm hitting the right spot?
A little forward.
This way.
This way?
Yeah.